So we looked into the possibility of using photosensitive sensors within the system, and what these sensors do is they capture the target's luminescence at impact and then send these images to an image processing system, which then compares the wavelength and intensity of the light to a known kinetic energy value that was calibrated before the system was used. But there's some drawbacks to using this system for a Taekwondo electronic body protector, and one of them is that a solid impact plate is necessary, which is usually steel or titanium, and that would be cumbersome to wear during a Taekwondo match. Also, if one were to hit the same spot repeatedly, then the photosensitive sensor stops working, and finally, it's not dynamic enough to use during a match.
So the other sensors we looked at were accelerometers, and they operate determining acceleration from an area of impact and using that to determine the force. So this requires a little more calculation to it, so we've kind of looked at other sensors. Strain gauges, their electronic properties get warped on impact, or the actual device gets warped on impact, and the electronic properties change, which allows the properties to be measured and the change to determine the force of impact. These need a power source, so that's an added contribution to the actual body protector to consider, but they are inexpensive and they're small in size, so we'd have to buy a lot of them and implement it that way. And then we looked at piezoelectric sensors, which are self-generating, so it doesn't need a power source, which is the bonus of that, and they operate similar to the strain gauge, where the properties, when you hit it, it actually generates a voltage. So it's not similar, but it generates based on the impact. And so we've considered that one to be the best option, and our idea to implement it is to use a bunch of small piezoelectric sensors and scatter it throughout for impact detection, and to use that to reduce the cost by not using bigger sheets of it.
So another thing that we're going to have to look at is the software, which is going to handle and process all of these signals. Currently, each company uses their own software. So, for example, Adidas, Dato, they all have their own proprietary software. Since we're going to be implementing our own extra sensors, like the gyroscopic sensors, we will need to write our own software. We have a few options, depending on what platform we want to run this on, whether it's a PC or Android or iOS device, and that will determine eventually what language we're going to write this in.
We've been attempting to establish a relationship with Dato in order to find either some design schematics or maybe an engineering sample, and through our communications we've established they are starting a new project soon and we might be able to help them, but we are currently waiting to hear back from their lead engineer for more information.